Hi here, we'll start with the chapter 1 chemical reactions and equation. Okay, so what is chemical reaction? So, whenever a chemical change occurs, what changes? Chemical change occurs, we say that chemical reaction has taken place. So, whenever there is a chemical change occurs, we'll say that it is a chemical reaction. Okay, how do you know that a chemical reaction has taken place? Okay, how do we come to know that a chemical reaction has taken place? Means when we observe that the nature and identity of the initial substance have somewhat changed. That means if there is some change in the identity or nature of the substance. If you observe the nature and the identity of the initial substance have somewhat changed, then we can say that chemical reaction has taken place. So that is change in the state, that is liquid or gaseous or solid state. Okay, change in the color happens, evolution of gas, change in temperature. So if these things happen, we say that a chemical reaction has taken place. Okay. So we'll see some activities. What is the we have said no change in the temperature, change in the color, change in the state, evolution of gas happens. We can say that there is a chemical reaction has taken place. So your first activity is clean a magnesium ribbon about 3 to 4 cm long by rubbing it with a sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp or burner and collect the ash. Okay. So what is that? So can show it in the picture. See, using a spirit lamp or burner, we are going to burn a piece of a ribbon, magnesium ribbon. Okay. Say for example 3 to 2 centimeter long. Okay, before burning we have to rub the ribbon with the sandpaper. Okay, we have to rub the ribbon with the sandpaper. Okay, then burn it. You will collect the ash. Okay, so this is a magnesium ribbon. This is a tongs. This is a burner. This is a watch glass. The name of this plate is watch glass. So we can collect this ash. Okay, so what you observe from this means a magnesium ribbon burns with a dazzling white flame and changes into white paper. Okay, so how it burns? It burns with a dazzling white flame and changes into white powder. That white powder is called magnesium oxide. What is the product form? Magnesium oxide. What is the color of the magnesium oxide? White. Okay, it is how it is formed? It is formed due to the reaction between magnesium and oxygen. What is this? Magnesium and oxygen present in the air. It reacts with the oxygen present in the air to form magnesium oxide. Okay, that means magnesium plus oxygen in the presence of heat, a magnesium oxide has been formed. Clear? Magnesium oxide is white in color. We will get a white powder. Okay, so this is your first activity. What is the first activity? You have to clean a magnesium ribbon about 3 to 4 cm long by rubbing it with a sandpaper. Why we have to rub it with the sandpaper means actually magnesium is a very reactive metal. Okay, so it already reacts with the oxygen present in the air and a small layer of magnesium oxide already present on the ribbon. Okay, but that magnesium oxide is a stable compound. Okay, so it will not allow the magnesium to react with oxygen to form magnesium oxide. So we have to remove the magnesium oxide already formed on the ribbon, magnesium ribbon. So we have to use a sandpaper to rub that and remove the magnesium oxide, so that below that magnesium metal will be there. So it will react with oxygen and form magnesium oxide. Clear on this? And your second activity is, okay, what is what is the reaction? We have seen that the magnesium plus oxygen in the presence of heat form a magnesium oxide. Totally a different compound has been formed. Okay, so we can say that a chemical reaction has been taken place. Okay, next, what is the next activity? Chemical activity 1.2. take a lead nitrate solution in a test tube. Okay, add potassium iodide to this solution. Take in a lead nitrate solution and add potassium nitrate to this. Okay, so what is your observation means? The yellow color precipitate is formed. So that is insoluble thing is formed. That is, what is the color of the precipitate? Yellow color precipitate is formed. That is lead iodide. Okay, what is the product from? Lead iodide along with the potassium nitrate, which is colorless. Okay, okay. This lead iodide is yellow in color, whereas potassium nitrate is colorless. So what is the reaction? When lead nitrate, this is lead nitrates, the color, this is colorless. Okay, this is a colorless solution, reacts with potassium iodide. Potassium iodide also colorless. Okay, when you add these two, potassium iodide to this lead nitrate, what is the compound form, new compound form? Lead iodide. Okay, lead iodide, which is yellow in color, it will precipitate. Precipitate means what? So test tube, if you mix this potassium iodide like this, while mixing, the precipitate, yellow color precipitate will settle down. It's insoluble and a clear solution will be there. Here the clear solution is there. This yellow color precipitate is your lead iodide, and this clear solution above this is your potassium nitrate, which is colorless. Okay, you can see the yellow color precipitate. This is yellow in color. Okay, so here what is the chemical reaction takes place? We notice that there is a change in color. Okay, change in color, change in state of the liquid, because it is solid, so it will settle down. Okay, it is a precipitate. Okay, so when lead nitrate react with potassium iodide, it gives lead iodide, which is yellow in color. Okay, both these are colorless. When react together, it form yellow color precipitate along with the potassium nitrate, which is colorless. Okay, so this is your second activity. Next, third activity is your take a few zinc granules in a conical flask or a test tube, add dilute sulfuric acid, not concentrated, it is a dilute sulfuric acid or hydrochloric acid or sulfuric acid. Okay, what will be your observation? See, so take a conical flask, take the dilute sulfuric acid in it, put the zinc granules. Okay, what would happen means hydrogen gas will be evolved. Okay, what has happened? The hydrogen gas will be evolved. Okay, while evolving, while liberating the hydrogen gas along with the bubbles, see, you can see the bubbles here, bubbles. This is hydrogen gas form. While liberating this hydrogen gas, it liberate the temperature, right? Temperature will also increase. Okay, if you touch this, it become the conical flask is very hot. Okay, so what are the observation when a zinc sulfate is put, zinc granules are put in the hydrochloric acid or sulfuric acid? Zinc sulfate and hydrogen gas is formed. What is formed? Zinc sulfate and hydrogen gas is formed. Means when zinc react with dilute sulfuric acid, H2SO4 means sulfuric acid, gives this the zinc replace this hydrogen. Okay, zinc sulfate plus hydrogen gas. Okay, hydrogen gas is evolved. Likewise, zinc plus hydrochloric acid, dilute hydrochloric acid gives zinc chloride plus hydrogen gas. Okay, the conical flask felt hot from outside. If you touch the conical flask, it will be very hot. Okay, this is your third activity. So what are the possible questions that can be asked from this introduction part is, only few questions can be asked from this introduction part. So what is this? When a dilute sulfuric hydrochloric acid is added to zinc pieces taken in a test tube, what would happen? No changes takes place, or color of the solution becomes yellow. the pungent smelling gas get liberated. Small bubbles of hydrogen gas appear on the surface of the zinc paste. We are seeing the activity, right? So what when the zinc granules in a when you put the zinc granules in the hydrochloric acid or sulfuric acid, what happened? The hydrogen gas will be evolved, right? So what is your answer? Small bubbles of hydrogen gas appear on the surface of the zinc paste. Okay, so this is your answer. Next, complete the following chemical reaction with the correct option. Lead nitrate react with potassium iodide gives dash plus potassium nitrate. So we have seen that in activity 1.2, when lead nitrate react with potassium iodide, it gives lead iodide plus potassium nitrate. So lead iodide. So your option is lead iodide, PbI2. Next, the chemical formula for magnesium oxide is, what is the chemical formula of magnesium oxide? MgO. Okay, okay, what happens when lead nitrate react with potassium iodide? What happens when lead nitrate react with potassium iodide? They will not react? No. Large amount of hydrogen releases? No. Yellow precipitate of lead iodide and potassium nitrate will be produced. Okay, what would happen when lead nitrate react with potassium iodide? This yellow precipitate of lead iodide and potassium nitrate will be formed. When a magnesium ribbon is burnt in air, the ash formed is, what is the color of the ash formed? White. The color of the magnesium oxide is white. If the magnesium is gently heated, it forms, the magnesium, we have heated this magnesium ribbon, right? What is formed? Magnesium oxide is formed. Why should a magnesium ribbon be cleaned before it is burnt in air? This is important. Okay, why should a magnesium ribbon be cleaned before it is burnt in air? I told you before, it is a very reactive metal. So you have to frame a sentence, you have to write. I have noted only the points. Okay, it is a very reactive metal. So when exposed to air, it reacts with oxygen to form a layer of magnesium oxide on its surface. Okay, so MgO is a very stable compound. Okay, already a layer of magnesium oxide is formed on the ribbon of magnesium ribbon. MgO, that is magnesium oxide, is very stable, so it will not react with anything. Okay, it will not while we are heating, it will not allow the oxygen present in the air to react with the magnesium metal. So first it prevents further reaction of magnesium with oxygen. So what we have to do, magnesium ribbon is cleaned by sandpaper to remove this layer. Once the magnesium oxide layer has been removed, this magnesium metal will be exposed to the air. Okay, then we will get magnesium will react with the oxygen in the presence of heat and form magnesium oxide. Okay, next, list 4 observations that helps us to determine whether a chemical reaction has taken place or not. Okay, what are the 4 observations? 4 observations that help us to say whether the chemical reaction has been taken place. Change in color, change in taste, state, and change in temperature. Okay, then evolution of gas. We have seen that in this activity 3, we have seen the evolution of gas has taken place. In the activity 2, we have seen the change in the color of substance has taken place. In the activity 1, we have seen that a new compound has been formed. Okay, thank you.